Okay, so now I'm going to do the last three on page number 2. All right, so when I go ahead and do this one, I want you to look at number 5 here. Is now if you pick u as negative 5x, is that its derivative out front? No, so I have to use parts. Okay, I'm going to use the tabular method on this one. So you can still get the same answer using the other one, the regular method. So I'm going to do 4x, 4, and 0. dv is e to the negative 5x. And I'm going to integrate that. So when I integrate it, I get e to the negative 5x. But I'm going to get a negative 1/5 out front. Integrate it again, I'm still going to get e to the negative 5x. But now I'm going to get a positive 1/25 out front. Because one other thing I have to do is, remember, I have to go plus, minus, plus. Then I go on the diagonals. So what do I get when I multiply these together? And I don't have to integrate again using this, so I get negative 4/5 x e to the negative 5x. Then I do the second one here, and I'm going to get negative 4/25 e to the negative 5x plus c. Okay, so I'm not going to have another x on that second term, because remember the powers on the x's decrease as you go. Okay, all right, so now let's go look at number 6. All right, so it's not a natural log, because if I pick the bottom as u, the derivative is not up top. So I want to next look is, can I factor that denominator? And in fact, I can factor it. So it's going to be some number a over, and this is x minus 3, x minus 8. So I'm going to do a over x minus 3 plus b over x minus 8. Okay, so I'm going to set this up. So I'm going to get x plus 5 is equal to a times x minus 8 plus some number b times x minus 3. All right, so I'm going to pick some convenient values. Well, to avoid a system, I'm going to use 8 and 3. When I use 8, I get 13 is equal to 5b, so b is equal to 13/5. When x is 3, I get 8 is equal to negative 5b, so b is negative 8/5. Okay, so if I go integrate this, I'm going to get, well, I'm integrating 13/5 over x minus 3 minus 8/5 over x minus 8. Now we have a dx around the whole thing. So this becomes 13/5 natural log of the absolute value of x minus 3 minus 8/5 natural log of the absolute value of x minus 8 plus c. Okay, I really can't combine those because my coefficients here are different. Okay, or certainly not in a nice manner. All right, so let's go do the last one. So we got to think about this. How am I going to approach it? So I got a couple options to look at. Is, well, if I pick the bottom as u, is that its derivative up top? And it is. So it's going to be a natural log. So I'm going to let u is equal to 125x plus 4. So du is therefore 125 dx. Well, do I have that on top? Well, I have a piece of it. I have 12 over 125th. Okay. All right, so what does this become? It becomes the antiderivative of 12/25 du over u. Okay, we're going to go change our limits also. So when I plug in 1 to this, I get 129. When I go plug in 2 into that, I get 250 plus 4 is 254. So now I don't have to substitute them back in. Okay, so what do I get? Well, I get 12, that should be a 1/25, 12 over 1/25 ln of the absolute value of u, and now we're going to go plug those in, 129 and 254. But the nice thing about it is, if you remember with logs, because this is going to be a subtraction, it's going to be the quotient of those two. So I get 12 over 1/25 ln of the absolute value of 254 divided by 129, which I know, by the way, you all know the decimal approximation for that, right? Yeah, right. Okay, all right. Hopefully this one helped. So that concludes page 2 then.